Hey, we still continue, still, I think, 10 hours left in this conference. And now we have another speaker here. Hi, Chris.
Hello there. How's it going?
I'm doing great. Still in here with my coffee.
Excellent, excellent. Yeah, I finished mine off, so I've got nothing left in here, but I've got some water on the side, so just in
Go
case
ahead,
I need
take.
it.
Take 1 minute, go.
Oh,
Look for
I'm
more
good.
coffee. Yeah, now you will be speaking.
Exactly. I'll have all the
And
jitters. I'll talk about 5,000 miles an hour, and no one will understand me.
welcome. Yeah, and now Chris will be working about refactoring. It's a great topic, and
Great.
yeah, we continue here in the first stage as a host, and okay, take coffee and just prepare anything to hear this great topic that will be continuing. Go ahead. I will leave you with your slides. Okay,
All right.
go ahead
Well,
and
thank you.
see you in some minutes.
Sounds great. Thank you, Denny. I really appreciate you passing the torch to me, and I'm excited to be here. It's been such a great conference, and I'm sure everybody here has gotten a lot out of this. And I'm excited because I get to talk to you about refactoring, and this is something that I've learned about really just in the last couple of years. Um, it's something that I've actually aspired to learn for like the vast majority of my coding career, but I was always intimidated by it. Like it was always really smart people who knew far more than I did who would talk about refactoring, and I just felt lost about it. But it turns out there's a lot of misunderstanding about refactoring, and I want to clear it up because being able to confidently refactor your code will multiply your effectiveness and bring you so much more satisfaction in your work. So let's dive in, right? What is refactoring? Refactoring is improving code without changing its behavior. Now, this is a definition that most people don't seem to know, at least in my experience, because on the teams that I've been a part of, when they've talked about refactoring, they've meant that, well, somebody needs to fix something. And that's not quite refactoring. You see, usually what happened was on the projects I've been on, project management have decided that there's something wrong with the code base and they need to take a developer away from creating new functionality to do something new, whether it's clean up code, reduce technical debt, or introduce a new dependency, or in other words, fix something, right? And so someone would go off, usually one, maybe two or three developers would go off and like kind of fix the code. And then we'd have like all this pain in bringing their code back into the main line where we were all working, right? It was painful. And that's not refactoring. I mean, you can call it reducing technical debt, you can call it cleaning up code, but it's not refactoring. Refactoring is a tool that improves the design of your code and how it communicates. So that's what refactoring is. Let's describe why we refactor. We refactor to make our code more understandable and to support new directions. These are the two primary reasons why we do that. So let's look into this a little bit more. When Guido van Rossum was creating Python, he had a number of guiding principles, one of which was code is read far more than is written. And this is such a great insight because we need to write our code in a way that drives understanding of what it does, right? Let's, for example, look at a piece of code. Now, this is an API endpoint that calculates the price of a lift ticket for a ski lodge. And looking at this code, I'm reminded that computers will execute code no matter how confusing it is to humans, right? So we need to write code that explains the reason why our code does what it does. We need to write our code in such a way that somebody new to the code base should understand not only what the code does, but how many variations there are in its behavior and how that variation varies, right? So you've had a little bit to look at this code. Let me scroll down so you can see the rest of it. I want you to think about this. Like, how would you feel if you had to maintain this code? Do you feel like you understand this code and what it would cost? If you needed to add a new lift ticket, how would you do that? Let's compare that to a refactored code that does exactly the same thing, right? This is much more clear that there are really only two types of tickets, right? And the primary way that it varies is on the age of the person asking for the ticket. Now, I want to say the code on the left is not bad code, right? I mean, I've written code like this. This is code that actually works, so it's not bad code. But the code on the right is so much more readable and understandable, and that's what we want to achieve. One of the things we want to achieve when we refactor. I should also pause. At any point, ask questions in the chat. I'll have some extra time at the end of the talk, so we'll be able to I'll be able to answer them. So that's one reason why we refactor code. The second one is to support new directions. Distinguished computer science professor Terry Winograd once wrote, "The main activity of programming is not the origination of new independent programs, but the integration, modification, and explanation of existing ones." So he's an academic, and it's a little hard to understand exactly what he means, right? But essentially what he's saying is anytime we program, the vast majority of the time that we program, we are not writing new code. We are modifying what's already there. We are explaining what's there to others, whether through documentation or meetings, or we're trying to integrate things together, right? He goes on to say that it's extremely difficult. Whoa, whoops. Gave away one of my, sorry. Oh no. It's extremely difficult to modify existing programs, the cost of which is almost never measured, but in at least one case, it exceeded the original development cost by a factor of 100. That's staggering, right? It is expensive. It can be expensive to maintain code. And why is that? I think it's because one of the main reasons why is because we are under pressure to deliver new features all the time, right? And when we come to our code with a new feature, we look for code that is closely related to what we want it to do. And we kind of just add more code in that space to support what we want, right? And if we don't stop and think about the the design of our project, the overall design, and how to improve it, we end up increasing technical debt. It just add more and more as we go along, and it really makes it painful, right? And it gets to the point where, as I said before, somebody needs to go in and fix it, and we need to go through that pain to get our code back to some place where we can use it again, right? But thankfully, unlike these bricklayers, it is much more easy for us to update code that's already working so that brittle and stagnant code can become pliable and meet new requirements. And that is why we refactor. Now, question is, when should we refactor? I think there are two primary times we should refactor. One is before we add new functionality. And Kent Beck once said that for each desired change, make the change easy. Warning, this may be hard. Then make the easy change. So when you have a new requirement, this is like such the perfect time to refactor because you have something that says your code needs a change and there's a specific way that you should change it. And that's essentially what refactoring can do, right? You can look at your code and say, if we knew we were going to need to do this in the past, how would we have written our code? And then you can rewrite your code to do that. Next, you should refactor after achieving something. So the test-driven development community has this phrase called red-green refactor, and it means the red part comes where you create a test that where you use code that you wish already existed, and you run the test and it fails because the code doesn't exist. It doesn't do what you want it to do yet, right? So then you write the least possible amount of code to get it to change what it says. Eventually, you get your test to pass probably pretty quickly, and that's the green part. And now that you have a test that all your tests are passing, you can refactor your code so that it can be more elegant, more understandable, more readable, and you know that you don't change behavior because your tests don't fail. This is such a great idea because it separates two things that I think a lot of us kind of do at once. A lot of us try to burden ourselves with writing elegant code that solves a problem, when in fact, we should just write code to solve the problem and then make it elegant. So once you achieve something, look at your code and ask, is this code so clear that anyone can understand it, including me in 14 months? And then refactor your code to make it more explicit and understandable. All right, so I've been talking for about 10 minutes, and we've covered what refactoring is, when you should do it, and why we do it, right? I want to get into how, because this is like the things I've talked about. I were very helpful in my journey in learning how to refactor. But the thing that really made it so much more satisfying is finding a framework that really helps you refactor. And this framework has a name called the flocking rules. And it was created by these two developers in the Ruby community, Sandy Metz and Katrina Owen. And my hat goes off to them. I appreciate these women so much because they spent years trying, they thought there was a way that you could teach refactoring to people who didn't know design rules, who didn't know design patterns, excuse me. Because the most of the advice that's out there about refactoring expects you to know design patterns, and they essentially will give you list of things you can do, a process to go through to say like, hey, if you want to go to this location, this is how you get there. You can start from where you are and end up here. The problem is what if you don't actually know exactly where you want to end up? And they created these set of rules, this simple framework where you can sit down in front of any piece of code and improve it by following it. So let me show you what it is first, and then we're actually going to go into a little bit of refactoring so you can understand it better. First part is you just identify what to work on. The second part is to make them identical, the two parts, what you identify to work on, and then you repeat it until you're satisfied. So again, you can take a screen capture of this if you like. It'll come back later, but I really wanted to work with some code so you can kind of understand this a little bit, so I don't have to kind of go into detail with this. So on the right, I have code that will generate the first two verses of the 12 Days of Christmas. And the first thing we would need to do if we want to refactor this is to identify what to work on. And we do that by finding the things that are most alike. In this case, we have two verses. Those are the things that are most alike. Now we need to identify the smallest difference between them. And I would suggest that it's these two words, right? First and second. Now we need to make them identical. And what's important about this part is we're going to start changing code. And so every time we change code, we want to run our tests to make sure we do not change behavior. So first thing we need to do is to create a component that will resolve the variations, right? We're going to create, say, a function, a class, a variable, anything that we can use as kind of an abstraction that can supply the variations. And in this case, we have this relationship where when our variable verse is 1, this thing that we create needs to be first. And when verse is 2, this thing needs to be second. And so we need to come up with a name to kind of fill this hole, these question marks. Because once we have a name, we can create a component and actually can create it can attract new behaviors, and it can be a thing inside of our program. This is, I think it's just going to be a simple function, and I'm going to use the word nth to describe it, right? Because if you want the fourth thing of it, fifth, I'm going to use the word nth and create a function with it. Next, we need to implement code to supply one of the variations. So I suggest we should just return first and move on. Now we replace one of the differences with a call to the component. And I keep forgetting, after each step, we should run our test. So we would replace first with a call to nth, run our tests. And this is the one that's most important, right? Because we've actually changed code that is currently working and it still works. We're good. Next, we can delete any unused code. At this point, we don't have any, so we can now repeat. If we come back to the top, it's pretty clear what we need to work on, right? we want to get those two lines to be as similar as possible. So let's jump straight down to implementing code supply, one of the variations. And we can type something like this. And if we were to run our tests, they would fail. And this is because in the verse one, we're not supplying anything into the parameter, right? We're not supplying an argument. And so our test would fail. So this isn't great, but thankfully all we need to do in Python is just to add a default parameter, run our tests, and we're good to go. Next, we need to replace one of the differences with a call. So we will just put that into our verse 2, run our tests, they're fine, and we'll look to see if there's any code we could delete, and not so at this point. So let's go back up, identify what we want to work on. We want to make the first verse match the second verse, so we'll change that here. We'll delete any unused code, which is that default parameter, and now we've done at least our initial step towards refactoring. We could always, like the one thing I love about this framework is that it's like kind of fractal in nature. You can really just sit down in front of any code. You could get distracted, get pulled away by a coworker, and come back, and you can just improve your code just by sitting down and kind of thinking about these rules. I'm excited about it. So to recap, refactoring. It's improving code without changing its behavior. It's a tool we use to improve the design of our code and to improve the communication of our code. We refactor to make code understandable and to support new directions for our code and our projects. You should refactor whenever you approach your code with new functions, with new functionality, or after you've achieved something. And these are the flocking rules, which are just, I highly suggest taking a screen capture of this and practicing this. Because the more you practice this, the more you're going to enjoy refactoring, the more you're going to just contribute value to your team. And I have this quote that really just nails this, right? By continuously improving the design of your code, you make it easier and easier to work with. But this is in sharp contrast to typically what happens, which is nobody refactors, and a great deal of attention is paid to adding new features as fast as possible. But if you get into the hygienic habit of refactoring continuously, you'll find that it is easier to extend and maintain your code. And as I've been recently learning, the way your mind works, if you can refactor code using the flocking rules, it gives your mind a chance to just kind of relax and think about higher level design. And the way that the flocking rules work, where you're doing something easy in the foreground and your mind in the background can work on design, it actually, your mind will start releasing chemicals that improve your emotions. This is some interesting research I found with the Extended Mind, the book The Extended Mind by I forgot her name, but it's something really interesting that I'm excited to learn more about. And speaking of which, if this is at all interesting to you, I have some great news, because I've created a thing called the Python Refactoring Toolkit, which if you go to my website, everydaysuperpowers.dev, there's a lot of information about the toolkit on there, including the free version that has so much stuff. My research is going to go into there. So if you want to keep up to date with that, please check that out. Otherwise, I'm Chris May, and I learned to program as an adult. I became a senior software engineer learning with Python, and I've quit because I want to teach people how to enjoy their lives, to have superpowers they can use every day. And please let me know how your refactoring journey goes, because I can't wait to find out. Thank you. I think I went a little fast, Denny. I'm sorry.
So fast. But in an interesting talk, it was almost 15 minutes. Oh my God, it's okay. But it was something like I was during the whole talk. Oh, he didn't present. He didn't say his person. What he is. First time I see you left it at the end. Say, who is Chris? Who is the
Indeed.
the speaker on this talk?
I thought I
Okay.
would experiment with that because there were times where I feel like it takes a lot to get over that hump, but so I'm going to try putting it at the end just to see.
Okay, we have a question in
Mm.
the chat. Oh, shoot. What do you think about the formatter like black?
I love formatters and tools that can help make your code more expressible, right? Um, I I feel like there's okay. Let's start with black. I love black. I love it came out. I technically use blue because I'm somebody who loves the single quotes instead of the double quotes. But the beautiful thing about them is that it eliminates it helps your code just look the same, right? And so it eliminates a lot of these discussion points on teams, which can sometimes be points of contention which don't need to be there. So black, wonderful. I love blue. Um, but also things, even there are programs that can help you refactor. The one that comes to mind is Sorcery. I use it in my PyCharm instance, and I even with the flocking rules, I kind of had this sense that I need to do it myself, right? I need to like go piece by piece and figure out exactly how to elegantly format this code. But then one day I was like, let's see what it can do. And it just saved me so much time. It took away the need to like think about every single thing. And instead, it just got to the point where now I can figure out how can I make my code more understandable. And that was a wonderful thing. So I say black, awesome. Like any tool that you can use to make your life easier, use it, and listen to others to see what tools they are using.
Yeah. So, something funny in the chat? Check. Couldn't say, I would cry if I had to maintain that code.
Indeed,
No,
indeed,
no, no, no. Don't cry. Don't cry. Chris can help you. And another question in
indeed.
the chat.
Hmm.
And okay, it is a good tool to help to keep the code clean. Okay, yeah.
Good question. I wish I could understand it a little bit more. So, is there a good tool to keep the code clean? That's a good question. Um, I I'm trying to think. There's a thought that's going through my head about um, I guess I guess it depends on how exactly you want to keep code clean. So I'm going to say off the top of my head, there isn't any that I know of. I know of things that like will you know maintain a certain level of test coverage. Things like Black, iSort, PyCode style will kind of help keep your code clean, but it won't necessarily help keep your code understandable. um, that's kind of where the human level comes in, right? So I don't know. At least that's as much as I can think of at this time.
You have some fun in the chat. Check. I thank for the
Oh,
inspiring talk.
excellent. Oh, good.
uh, I'm gonna show you in the screen another question for you.
Oh, okay.
Maybe it's easily to understand. Yeah, you can
Yes,
you can repeat it
yes.
for people who is just hearing this. How do you
That
convince non-technical stakeholder of the importance of refactoring? Yeah.
yes, absolutely. Okay, so because there was actually something I came across that I wanted to include where this exact tension was coming up because project managers, they just want features, right? They think that features is the easiest measurement to say if the team is succeeding, and if things are going well, right? So this is part of the reason why I love refactoring when you have a new piece of functionality, is because I find that there's this mentality that is, it has to take a lot of effort to refactor. We have to take a month to refactor when once you kind of practice it, and this is the big thing, is practicing, right? There are actually a lot of refactoring practice katas that are out there where you can kind of grow. And when you kind of just get in the practice of it, you could drastically reduce your time of refactoring. So there's part of me that says, kind of go skunk works with it. Don't tell your project manager that you're refactoring, but talk to your team about it, right? Because if let's say one of your members of the team is working on a file that you're working on, and then they pull the latest code and look at it and it's completely changed, that's not necessarily a good thing. But if your team kind of weigh in, and they might actually be able to help you determine like the trade-offs you make for refactoring. Trying to think if there's any other any idea. The other thing, like if you do, because I think part of it too is a lot of times project managers are non-technical, so they don't quite understand how they, if a code works, the code works, and that's good. But the understanding is what helps, right? If you can reduce, if you can write code that is more understandable, the chance of you writing a bug is reduced, and the chances of you writing the next piece of functionality quicker is improved. So if you could kind of talk to your project manager on that level, it might take a little while to kind of find the right language and the right level to talk to them on. But I bet, I know of project managers who have been convinced. I wasn't there for how they to figure out how they were convinced, but I think it's definitely very doable.
Hope so, Kuram. This was a great answer for you. But people in the chat are asking for tips. The next three questions are about having, if you have some tips about framework testing. But okay, let me take the question at the middle. You still have, okay, 5 minutes. You are lucky.
Yeah.
Check. Tanim. Will new functionality also include upgrades in the under oh my god underlying language, Python upgrade, for example?
Yeah, absolutely. I would say so, right? Recently Python introduced the switch statement or the match statement. I keep forgetting exactly, but the wonderful thing about it is that you don't have to like go back immediately and change your code. I think that's another thing, that another misunderstanding about refactoring is that just because something new shows up, you have a new framework or something new in the language, it doesn't mean you have to go back immediately to fix something. If it's working, it's working. You may never need to touch that code again. But if you are touching code, then absolutely take advantage of a new framework, or in particular, if you're new on a new version of Python, which everybody should be pretty new, um, you should upgrade to Python and use the new features of that language. I've lost audio, I think, but
Yeah, it's me. It's me.
oh, okay.
Sorry, it's me. The last one. Okay. Something. Okay, testing. Do you have any tips on testing frameworks?
Uh, it, I would say I really enjoy PyTest. I learned a lot from Brian Aaken's book on PyTest. Um, I really appreciate how it allows you to write more Pythonic code and just insert assert statements to test your code. I am actually also doing a lot of research on testing because I think refactoring and testing are two really great test-driven development and refactoring are two practices that are really great to do, but they're very hard to learn. I think the flocking rules is an incredible framework to help people refactor. I'm hoping that there's a way to help people with testing, because kind of what I've learned is that there is no one way to test your code. And there's a lot of opinions out there, but like everybody does it slightly differently. So go to my website, sign up for my newsletter, and I'll definitely like to keep you involved to let you know.
Uh, oh no, I think it's this. Hey, okay, can you hear me now? I'm just.
Yeah, I can hear you.
I really enjoy your talk. And now, okay, thank you so much for your
Thank
time.
you.
It's a
Yeah,
pleasure having you here with we all. And now we will continue with the next speaker. Let me introduce Alison Orellana. Oh, still have 2 minutes left. Well, no. Thank you so